So today we'll talk about section 2.3, which is about solving absolute value inequalities. So the procedure here remains very similar. So we'll start by isolating the absolute value. We'll rewrite the absolute value inequality as two linear inequalities. We'll solve each inequality. And now we don't get to check in the case of inequalities. What we'll do instead is we're going to plot each inequality on the number line. And then, hello. Goodness, Ms. Bond. Make you carry that all the way back. And then we're going to decide if it's an and or if it's an or inequality. And I'm going to put a little asterisk on 3 because there's something important we need to remember here on step 3 as well. But we'll get to that when we do an example here. Connor? Of course. So let's do an example. So let's say we have the absolute value of x plus 3 plus 1 is greater than 4. The first step we're going to want to do is to isolate the absolute value. What should be the first thing I do here? Good. Subtract 1 from both sides. Good. Now what? Hattie? Is that a hand or you just... Oh, that's okay. You can leave your hand like that. I just wasn't sure. Yeah, we're going to rewrite it as two linear inequalities. That's correct. So the first linear inequality is going to be just like we'd write the linear equation. I'm going to just copy the exact same thing except drop the absolute value. For the second inequality, we're going to copy the exact same thing except we negate the right-hand side and flip the inequality. That is the most common mistake students make when solving these absolute value inequalities, is forgetting to do that flip. So make sure you remember to flip the one that becomes negative. Okay. So from here I can solve each of these two inequalities separately. Yes. Yes. Yeah, you flipping no matter what, regardless of what sign that right-hand side turns into, we always flip. Just like if this right-hand side was already negative, we still make it negative again to turn it positive. So we always do that. We always do the flipping. So now we've solved each of the two linear inequalities separately. The question becomes, is this an and inequality or is it an or inequality? To make that decision, what we're going to do is we're going to graph our two solutions on the same number line. So if I was to graph x is greater than 0 on the number line, I'm going to start with making a mark at 0. That mark would either be a filled-in circle or an open circle. Which one would I want to use here? Open. Why open? Great, because it's a strictly greater than inequality. It's not or equal to. And then I should draw my arrow going in which direction? To the right or to the left? To the right, because the things that are greater than 0 live to the right on the number line. Now let's graph x is less than negative 6. So again, I'm going to start by making a mark at negative 6. What kind of mark should I make at negative 6? Open circle is correct, again, because it's a strict less than rather than a less than or equal to. And which direction should my arrow be pointing? To the left or to the right? To the left. When my arrows point in opposite directions, this is the or situation. So my final answer would be x is greater than 0 or x is less than negative 6. So what that means is, if I pick a value like x equals 5, that's something that's greater than 0, and I plug that in to my equation, it should still satisfy the inequality. Which it does. Or if I pick something less than negative 6, say negative 8, and plug that in, and check to see if that satisfies the inequality, it does. If I were to pick something in between negative 6 and 0, though, say negative 1, I see that it does not satisfy the inequality. Does everybody kind of see why we need the or sign there? Because I can pick from this side or from that side. As long as I'm picking from one place or the other, I'm going to get something that works. Is that okay with you guys? Now, all this stuff in green was just like an aside. You don't actually have to do this during the solving process. You can use it as a way to kind of confirm to make sure that you've done the problem correctly, is that if I pick things from both locations, they should both work. And if I pick something from outside of those two locations, that should not work, is a fine way to check if you're looking for a numeric checker. But it's not necessary, per se, to complete that problem. Everybody okay with that idea? Let's do another example. What should I do first here? Good. Massimo, what's up? Oh, sure, of course. Uh-huh. Then what should I do? Yeah, split it into 2. So the first one, nothing changes. And what should the second one be? Yeah, so I should have x minus 2 is greater than negative 4. And then I can solve these two independently. So I have x is less than 6, and x is greater than negative 2. To figure out whether this should be and or, I'm going to go ahead and plot this on the number line. So if I start at with the x is less than 6, I start by making a mark at 6. What kind of mark should I make? Open. And which way should my arrow point? Left. If I do x is greater than negative 2, I need to make a mark at negative 2. It should be open. And which direction should the arrow point? To the right. Notice how these two arrows point at one another? That tells me this is an and inequality. So any answer I pick must be between negative 2 and positive 6. If I pick something outside of that range, it should not work. Also worth noting that if you check your answer, or if you're taking a standardized test like in an ACT, it's unlikely they would format their answer in this way. They would likely write this as negative 2 is less than x is less than 6. Just so you know, that's the alternative way to write an and inequality. I will accept both, but if you're taking a multiple choice math test, like standardized math test, it's unlikely they would represent their answer with the word and. They would likely write it as one compound inequality. So far, so good? Everybody still on board? Sure. Ooh, excuse me. Who's got a case of the yawnies? Yeah, happened to me. Okay. Let's take, for example, 2 times the absolute value of 4 minus x plus 15 is greater than 21. What should I do first here? Good, I'll subtract 15 from both sides. Then what? Good. Divide by 2 on both sides. Now what? Good. We'll split that into 2. And we'll remember on the second inequality that we flip the inequality symbol and negate the right-hand side. Then we solve these each one at a time. What should I do for the first one? Well, I subtract 4, right? Got to solve it first before we can plot anything. So that gives me negative x is greater than negative 1. Then what do I need to do? I'm still working on that first one. It's not quite done yet. Great. What do I have to remember when I do that, though? Yeah, so whenever you multiply or divide both sides by a negative, you got to remember to flip that inequality sign, like we did there. Now we're ready to do the other one. So we'll subtract 4, as was suggested earlier. And then what? Good. Divide both sides by -1. We got to remember to flip our inequality. So that one was kind of tough. We had to do a couple of flippings in there. And now we'll plot these on the number line. So at 1, we're going to use the open circle and draw the arrow to the left. And at 7, we'll have an open circle and draw the arrow to the right. What word do we use when the arrows point away from each other? 4. Can we ever have a situation where both the arrows point the same direction? Could I have a situation where it looked like this? No. What does this mean? It means you forgot to flip your inequality at some point. The likely point is right here. When you negated that one equation, it's likely that you just forgot to flip your inequality. Yes? Of course. What do you guys think? Does this feel pretty doable still? Good. It should. This isn't too bad. But that's about as tough as it gets for these absolute value inequalities. What I want to do now is backtrack to these absolute value solving problems. Because there's another situation that we haven't really looked at that I want to look at a little bit more. So we're just going to backtrack and circle back to solving absolute value equations for a moment. And I want to do a couple more examples. So let's say we want to solve the absolute value of 2x plus 12 equals 4x. So when we're solving an equation, our 4 steps were to isolate the absolute value, break it into 2 linear equations, solve the 2 linear equations, and then check. Everybody agree with that? So what should I do first here? The isolating's already done, isn't it? Everybody agree with that? So we're ready just to break this into 2 pieces. So far, so good. For that first equation, what should I do? I wouldn't do that yet. You could. I would get the x's together on the same side. So I'm going to subtract 2x from both sides. And now I'm in a position where dividing both sides by 2 makes sense. Or makes more sense. It did not make sense before. You could have done it before. It just makes things a little messier than it needs to be. And on the second equation, we'll start the same way. We're going to get the x's all in one place. And then we'll divide both sides by -6. So here are my two prospective solutions. Before I can declare them real solutions, though, I need to make sure I check. So we'll check the x equals 6 part first. So 2 times 6 is 12. 4 times 6 is 24. 12 plus 12 is 24, and the absolute value of 24 is 24. So that answer works. Let's check the negative now. So that's -4 plus 12 equals -8. So I have 8, absolute value 8 equals -8. That's a bunch of nonsense right here, peeps. So that one is extraneous. So I'm left with only one answer, x equals 6. This was a situation that we didn't see happen last time we met, right? When we were checking before, either both of them worked or neither of them worked. We hadn't seen a situation where just one of the two worked. Do you guys recognize that? That same thing happened in the homework over and over again. Either it was all or nothing. I want to point out to you guys that it can be just one of the two, but in order for it to be one of the two, we have to have an x outside of the absolute value. Now, does having the x outside of the absolute value on its own guarantee you it's going to be one of the two? No. You could still have both work. You could still have neither work. But now you can also have the situation where only one of the two works. I want to do one other example because there's a very important situation that most students make a mistake on. So I want to make sure that I do an example of that. So let's say we have the absolute value of 4x minus 1 minus 9 equals 2x. First thing I'd want to do is your instincts are right. Go ahead and say it. Yeah. Oh, can't do that because one is inside the absolute value, the other is outside the absolute value. Can't do that because one is inside the absolute value and the other is outside the absolute value. You don't want to distribute the -9 because it's not being multiplied to the absolute value. And in general, you don't want to be distributing into an absolute value. You can like break things out of it, like we did on the very first day, but you don't want to be pushing stuff in. We're just going to add 9 to both sides. Exactly as we would have hoped for. Now, can I add 2x and 9 together? No. So what do? I just write 2x plus 9, right? They're not like terms. I just write it on the other side with it. No big deal. Does everybody feel okay with that? Simpler than maybe we thought it was going to be, right? That's always a good thing, though. I'm good with things being easier than maybe we expected, right? It's when they're harder than are expected, that life is kind of disappointing. This is kind of nice. Okay, so just like before, we're going to break this into two separate equations. So the first equation, we just drop the absolute value and copy everything else exactly. It's in making the second equation that the majority of students would make a mistake. Even when I point out to them that this is a place that lots of mistakes get made, they still go ahead and make the same mistake. So the mistake would be if I wrote 4x minus 1 equals negative 2x plus 9. That is wrong. Why is that wrong? Elena? Yeah, so you're right. It's that when we negate, we have to negate the entire right-hand side. So that negative distributes to the 2x and to the 9, which I think is what you were saying, right? No.
I was thinking, like, make the 9
Oh. You're half right. So this is the place that if you are not shown this example, most students would make this mistake. I'd say practically all students would make that mistake of not negating the entire right-hand side, but just negating one part or the other, but not all parts. Can everybody see that? Okay. Okay. So now we're in a position where we can solve each of these separately. So the first one, 4x minus 1 equals 2x plus 9. What do I have to do there first? Go ahead. It's okay. It's okay to be wrong. It's not a big deal. Okay, you can do that. And then what else would you want to do then? Yeah, we move the constants to one side. So notice that on the right-hand side, there's no more constants. And on the left-hand side, there's no more variables. Right? That's the goal, is to get one side with the variables and one side with the constants. Right? Did it matter which side you put which on? Not really. I would have put them on the other side so I didn't have to deal with the negatives. But this is fine. There's nothing wrong with doing it this way. Well, you're doing fine. You've not done this before. You can't expect it to be perfect. That's an unrealistic expectation, to make no mistakes the first time you're doing something. Okay, now what? Divide by negative 2. That's correct. So I get x equals 5. All right. So the next one, what should we do here? Okay, I'm going to add 9 to negative 1. And what else are we going to do? Yep, subtract 4x from both sides. So there the variable cancels, and on that side the constant cancels. So I have 8 is equal to negative 6x. Notice there was no way in this one to not have, or to have no negatives, right? I was going to have a negative on either the constant or the variable, no matter what I did there. So, and then we'll divide negative 6 from both sides, and that gives me negative 4/3 equals x. How did I go from 8 over negative 6 to negative 4/3? I reduced, right? So 8 I thought of as 2 times 4. 6 I thought of as 2 times 3. And I reduced the 2's. Okay. But we're not done, are we? We still need to. Got to check them. So we have x equals 5. So I have 4 times 5 plus 1 minus 9 equals 2 times 5. And then on the other one, I have 4 times negative 4/3 plus 1 minus 9 equals 2 times negative 4/3. Put my question marks over the equal sign because we don't know if these are equal or not yet. Everybody okay with what I plugged in here? Now let's just simplify things down. So 4 times 5 is 20, and 20 plus 1 is 21. And 2 times 5 is 10. Oh my goodness, what did I do wrong here? That's a minus 1. I wrote plus 1s. There we go. Something smelled fishy there. And then absolute value 19 is 19, and 19 minus 9 is 10. So x equals 5 works. This one, how do I multiply 4 times negative 4/3? So I'm going to think about 4 as the fraction, 4 over 1. And to multiply fractions, I just multiply the tops together and the bottoms together. And similarly here, I think of that as 2 over 1. Okay. The next thing I need to do is negative 16/3 minus 1. In order to subtract two fractions, what do I have to have? Common denominator. What would the common denominator be in this case? 3. So to do that, I'm just going to multiply 1 over 1 by 3 over 3. So 16 minus 3 is negative 19, and then the denominator stays the same. The absolute value of negative 19/3 is just 19/3. And to subtract 9 from this, I need to have a common denominator. In this case, the common denominator would be 3. So I'll multiply 9 over 1 by 3 over 3 to give us 27 over 3. And 19 minus 27 is negative 8, and the denominator always stays the same. And that one checks out. So I have two answers in this case. Remember I told you, just because you had an x outside of the absolute value, you could still get 1, 0, or none. 1, 0, or none. 1, 2, or none as answers, right? We'll stop here.